All right, section 8 is going to deal with variation, and what variation deals with is when we have a pair of variables, and as one changes, the other one's going to change in some way or some fashion. So it could be that when my x value increases, that my y also increases, or as my x value increases, my y decreases. And so that's what we're going to look at here. So the first type is direct variation. And it says that when y varies directly as x, okay, there's some non-zero constant k such that y is going to be equal k times x. K is called what your constant of variation. Constant does not change. Okay, it stays constant, never changes throughout the whole process. Okay, so an example I use a lot of times is if you have a job where K is your hourly wage, it's not going to change. But if the number of hours that you work increases, the amount in your paycheck should increase as well. So that's why we look at with direct variation, both variables are going to be doing the same thing. Okay, so if X increases, Y is also going to increase. Now, if I solve up here for my constant of variation, okay, if I get X all by it, or if I get K all by itself, I get Y over X. I can set up a situation down here where I'm going to have my very first case, which is my Y1 over X1. So it could be that Y is how much you made in your last paycheck, X is the number of hours that you worked, and that's going to divide out to give you your constant, your hourly wage, and then the second week the same thing. Okay. What we're going to do is we're going to shorten this up. We don't necessarily need to find my constant of variation every time, but what I'm going to do is set up an equation that looks like that. I'm going to take my first y divided by my first x, set equal to my second y divided by my second x. Okay, now one way that I tell people to remember which one's which is with direct, we divide. Both of them have the d in it. So an example here, suppose y varies directly as x. Okay, so as soon as I see y varies directly, okay, I'm setting this situation up. Y1 over x1 equals y2 over x2. Okay. My first case is when y is 27 and x is 6. So I'm going to substitute that in for the y1, x1. Okay. My second situation is going to be my unknown. Find y when x is 10. So find y, so the top is what I don't know when y is 10. And now it simply becomes a ratio and proportion problem where we can do cross products. So 270 is going to equal 6y. Divide both sides by 6. And y becomes 45. So now kind of a little check here. What we can do is what I want to look at is what happened to my x's, what happened to my y's. So x went from 6 to 10, meaning it increased. So I expect then that my y value would also increase, which it did since it's direct variation. All right, second type, inverse. Inverse, sometimes people think about opposite, so what we can think about with inverse is that as x gets bigger, y is going to get smaller, or vice versa. Okay, sometimes we'll talk about this as indirect, okay, and then it kind of matches in with the direct idea. Okay, so it varies inverse, y varies inversely as x if there's some non-zero constant such that when I do y equals k divided by x. Okay, so an example here is that my constant is some number of miles that we're going to drive. So if we're driving, say, to Chicago, okay, and if I let x be the rate at one of us drives, okay, y is going to be the time to get to the destination. So if I drive 50 miles an hour, okay, and you drive 60 miles an hour, okay, the length of time because you drove faster is going to be less that you need to drive. Okay. So same idea here. What I want to do is I want to solve this for my constant. Okay, so what we get is my constant is going to be equal to x times y. So similar situation, x1, y1 is equal to that constant, which then, since it's always staying the same, is equal to x2, y2. But in the same way, I'm going to take that k out of there and just use this equation. Okay, and so again, how I remember this is if I remember direct divide, indirect, inverse is opposite, so that means we're going to multiply. Okay, so if y varies inversely, as soon as I read that, I'm setting this piece up. Okay, and in my first case, y is 21, x is 15. So y is 21, x is 15. Second situation, I'm finding x when y is 12. So I need to find x when y is 12. So now I just simply need to go in and do some algebra. So I'm going to take the 15 times the 21, simplify that left side, and then I'm going to divide both sides by 12. And again, you could always check this, make sure that 26.25 times 12 gives me 315, which it is. Okay, and then again, with my check, okay, my y value went from 21 to 12, so it got smaller. So when I look at my x value, I expect it to do the opposite or get bigger, which it did. All right, joint variation is a combination here. What we're doing is we're saying that we have some product, x and z. And what it really is when we say y varies jointly as x and z, is that there's one quantity, y, that varies directly, so we're going to divide as the product multiplication of 2 or more. Okay, 2 or more. In this case, it's x times z. Okay. So same idea. I'm going to take that y and divide it, because it's direct, by those x and z product. Okay, and again, if I get rid of that one, we're going to have that as my equation. Now, whichever one is all by itself is always on top. Won't always be that y varies, and so we can't always assume that's how it's going to be set up. They may say x varies jointly as, and so that means that's the one that's by itself, x, so that's how I know which one goes on top. Okay, so y varies jointly as x and the cube of z. So y is the one by itself, so it's on the top. Jointly, we're going to put these two things together. Now, you got x, and it's not always just a single variable. Sometimes it might be a cube, square, square root, things like that, and that's the case we have here, the cube of z. Okay, and so that's my first ones, and then my second ones. And it's the exact same expression, different subscripts. So first pile of information, y is 16, when x is 4, and z is 2. Find y when x is -8, z is -3. Now, because of the idea they said it varies directly, what I want to do in my next step is multiply the denominators together, because now what I'm going to look at is from here to here we're doing an increase. So in my numerators I'd also expect an increase. So I'm going to expect a value greater than 16 when I'm all done with this, okay, because of the direct variation idea. So cross products, 16 times 24 equals 8y, where y is going to equal 48. So we did indeed increase. All right, good luck with that.